Good afternoon to all. From today onwards, we are going to start our new lesson. The second lesson is kinematics. This lesson is very important in physics, which means we are going to study the concept of physics in movement. Okay, so listen very carefully. This lesson is very important for NEET oriented, also JE oriented. Okay, so listen very carefully. Student, let me discuss the definition of our topic. So kinematics is a branches of mechanics which deals with motion of object without taking force into account, which means the object is moving, there will be force is required. That force cannot be concluded in this topic. Then the word kinematics is derived from Greek word kinema, which means motion. Motion means movement. Okay, so in this lesson we are going to discuss only an object is moving. Students, next we are going to see some important topics in this lesson which we studied in our earlier classes. The concept of rest and motion. What is rest? An object remains same. That means the object never change its position, or otherwise there is no force is acting on an object, then it is said to be rest. Okay, some of the examples, the students sitting in the classroom while the teacher taking the class. The position of the student is considered as a rest while the teacher taking the class in moving from one end to another end, then he is said to be in motion, that is changing his position from one end to the another end while taking the class. Next one is motion. Right now we see an example, see the term of motion. An object is moving with respect to time while force is applying on it. Okay, that is he is the changing the position from one end to the another end. An object is moving. For example, while you are riding the cycle from school to home, that is a in motion. The next important topic is frame of reference. So the frame of reference is nothing but when an object is moving, in which direction and the representation of the position of an object is called a frame of reference. See the definition. If you imagine a coordinate system and the position of an object is described relative to it, here the relative is represent the movement. That such a coordinate system. Coordinate means the representation of position, whether it may be x, y, z, they are called some coordinate systems. Then it is said to be frame of reference. Then next we are going to see the Cartesian coordinate system. What is Cartesian coordinate system? At any instant of given time, the frame of reference with respect to which the object of the position is described in the term of position coordinates, that is x, y, z, which means the distance is measured. The position of the distance is represented in x-axis or y-axis or z-axis. Then it is called Cartesian coordinate system. Students, listen carefully. When the object is moving with respect to the time, then finding the position of the object is moving, it is said to be Cartesian coordinate system. We having three type of Cartesian coordinate system. One is x-axis, then y-axis and z-axis. Now see the diagram. This diagram represents the Cartesian coordinate system. So the x, y, z axis represent the three-dimensional. And another important 2-mark question, define point mass. See, point mass is nothing but the representation of the object in a dot, in a point size, that is considered as a point mass. To explain this motion of an object with as a finite mass, the concept of point mass is required and it is very useful. The mass of any object is to be assumed to be the concentrated at a point. So we just consider the whole mass as a single point mass. See the example. To analyze the motion of Earth with respect to Sun, which means we are going to calculate the rotation of the Earth with the center of the Sun. Then here the Earth is treated as a point mass. That means we are going to keep Earth as a small point because the distance between the Sun and Earth is very large. So when compared to that, we are putting the Earth as a small point. Okay, so this is a best example for representing the point mass. Students, next we are going to see the types of motion which is related to our day-to-day life. So here we are assuming only 4 types of motion. The first one is linear motion, then second one is circular motion, third one is rotational motion, and fourth one is vibratory motion. So these 4 motions we are using in our day-to-day life. Now we see elaborately. First one, linear motion. Linear motion is nothing but an object moving in a linear path. That is, an object moves in a straight. For example, moving of car in the road. Okay, another example, an athlete running on the straight track. Then another example, the particles falling vertically downward to the earth. So these are some examples of linear motion. Second type, the circular motion. Circular motion is defined as the motion described by an object traversing a circular path, which means an object moving around in a circular path. For example, the electrons revolving around the nucleus, keeping as a nucleus as the center, the electrons will moving around the nucleus. And another example, the whirling motion of the stone attached to the string. Then also another example, the motion of a satellite around our earth, keeping the earth as a center. Thus all the satellites are revolving our earth as in a circular motion. Third one, rotational motion. So this is very important motion, students. An object will move in a rotational path keeping as an axis. Okay. See, when during the rotation, every point in the object transfers a circular path about an axis, except the point located on the axis. See the example, the fan rotates. Okay, so the keeping at the axis, the wings of the fan is rotate. This is an example of rotational motion. See the next example, the rotation of a disc about an axis through its center. And also a very good example, you are playing with the top. Okay, so the nail act as the axis and it will be rotate the top. Then our best example, our earth is one of the best example of rotational motion. Okay, spinning of the earth about its own axis. And last type of motion is vibratory motion. An object or a particle execute to and fro motion about a fixed point. It is said to be vibratory motion. See the example, vibration on a string of guitar. If we disturb the string of the guitar, we hear a pleasant sound. How it is produced? The vibration of the string. Only the vibration. And next one, movement of the swing. We all play in a park, amusement park or any park. So if you are sitting in the swing, if you move to and fro, it is a best example of vibratory motion. Students, now we are going to discuss about motion in 1 dimension, 2 dimension and 3 dimension, which means the object covers in x-axis or xy axis or xyz axis. So first we discuss about motion in 1 dimension. So in motion in 1 dimension, the object covers only one axis. Okay, for example, an object moves in a straight. See our book example. Motion of a train along a straight railway track. The train will move in a straight path. It covers only x-axis. Next, an object falling freely under gravity close to earth. It also represents only one axis. Next one, motion in 2 dimension. The object covers both x and y axis. Now see the example definition. If a particle moving along a curved path in a plane, then it is said to be 2 dimension, because in a curved path it covers the 2 axes. Okay, see the example. A motion of a coin on a carom board. If we strike the striker to hit the coin, the movement of coin is considered as a 2 dimension. And next one, an insect crawling on the floor of a room, which means the movement of the insects on the floor is also considered as a motion in 2 dimension. And last one, motion in 3 dimension. So 3 dimension means the object covers both x, y and z axis. See the definition. A particle moving in usually 3-dimensional space has 3-dimensional motion, which means the dimension having 3 coordinates x, y and z. See the example. A bird flying in the sky is the example of 3 dimension. The random motion of a gas molecules. So we know the random motion, the zigzag path of the motion is called a random motion. So inside the gas, all the molecules will move like that. And also the flying of kite on a windy day, because the kite will move anywhere due to the air. So these are some example of 3 dimension. Students, today we discussed only some important basic concepts of kinematics. I hope you all clear. You just refer your book. Okay. Thank you.